Welcome, everybody. My name is Keir Storrie, and I'm here from the Verimatrix Cybersecurity Company, and today I want to talk to you about the mobile threat landscape. So the attacks and the attack vectors that we as software engineers are going to face when we release our applications into the real world. I've been a software engineer, a reverse engineer, a white, a black hat hacker for more than 28 years. So I've really experienced a huge escalation in the number and sophistication of attacks through to the current mobile platforms. So when we think about the threat landscape, we obviously need to start with mobile malware. So malware that is delivered to mobile phones with the intention of stealing data, making fraudulent transactions, and generally causing havoc. Now, some great examples of mobile malware are things like Gold Digger, which was quite a sophisticated Android banking Trojan. But what was interesting about it was a framework, and like any good piece of software, new hackers picked it up, ran with it, and made it even more sophisticated. Now, this was an attack that would actually lift money from bank accounts in Vietnam, and there was a few $100,000 worth of fraudulent transaction executed. And that quickly morphed to Gold Digger Plus and Golden Pickaxe. Now, Gold Pickaxe is one of the most sophisticated attack vectors out there because it uses a combination of phishing, social engineering attacks, and more importantly, mechanisms in order to bypass biometrics and multi-factor authentication on devices, allowing an attacker to gain credentials to banking mobile applications and to transfer money illegally out of those accounts. Now, the interesting thing about this was that the framework started on Android and then was picked up and quickly migrated to include iOS as well. So whereas previously people would say that, well, Android was the platform to attack, we're now seeing the level of sophistication spreading out in order to cover all mobile devices, but also embedded IoT devices as well. And this is not a problem limited by geographical location. Certainly Southeast Asia, where a lot of these attack vectors would begin, but now we're seeing them globally. And we're seeing that these attacks have got sophisticated mechanisms in them. It's not just task hijacking, key logging, screen logging, but certainly one-time password bypassing, two-factor authentication bypassing. So we're really seeing a massive increase in the level of sophistication of this malware. And that's even before attackers begin to use AI and ML in order to have much more adaptive solutions. So these are things that we need to be very aware of when we are developing our mobile applications, because generally people are focusing their digital lives on these devices. There are more than 21 billion connected devices around the world today, more than 7 million applications available across the Google Play Store and the Apple App Store, and that is a huge attack vector for things like dropper applications which will deliver malware to a device. You might think that you're downloading an innocuous game that's free, but a lot of these games have been discovered to actually have banking Trojans and mobile malware contained within them. So it's very difficult on a modern mobile with 50 applications, 100 applications per person to work out whether or not these applications are going to attack us. As app developers, one that we might be more familiar with is improper credential usage and API attacks. Well, that's really where most malware attacks begin. We want to look inside an application for APIs that we can abuse. We want to look for vulnerabilities in third-party packages that can be used against us. And we know that most applications will contain some form of credential, whether or not it's username or process some form of credential, whether or not it's usernames, passwords, API keys. These are fundamental pieces of data that are going to be processed by our application. And certainly the APIs that attackers are going to be looking to hook or dynamically instrument or to steal credentials from. Overlays are a great example of that. To an attacker, an overlay is the perfect tool. It looks like and acts like the UI in your application. It starts up exactly when your application starts up, and all it's doing is stealing the credentials from that application, transmitting it to a third-party server. And these are the reason that we see on the dark web collections of 10, 50, 100,000 whitelisted usernames and passwords that can be used to scale up an attack against a service via the mobile application and the back end. Independent analysis has shown that some of the biggest applications, more than 16,000 analysed, over 2,500 of these have contained an API key or a secret that was significant when used in scaling an attack against that particular service. So really what we're talking about in terms of very wide-ranging attacks are what we call repackaging attacks. This is where we download an application from the Play Store to a laptop. We use very simple tools in order to decompile the APK or the APKs, gain access to those credentials, inject malware into that application, repackage it, and then deliver it back to the market, either via a side-loading store or via a clone on the Google Play Store or via some other form of phishing or social engineering attack. And this is probably where the state of the art is heading today, because we have the ability in order to inject gadgets or malware into an application that will dynamically instrument that app. So I can tell which activity, which intent, which broadcast, which receiver is running inside the application, gain access to that class, gain access to all of the methods of that class, and then with some very simple JavaScript, take control programmatically of that API. So that means that I can see which parameters are being passed to a method to modify return values from that, effectively obliterating any programmatic control that the application is intended to have. One great example of that recently in the last few years was WhatsApp Gold, a great social engineering attack. Everyone wants to think that they're a gold or a platinum user, and therefore they will go for that version, especially if it's free. Yes, I'm a gold user, give me that functionality. To the user, it looked and acted exactly like WhatsApp. However, there was a supply chain attack inside this application, and all it would do was record your messages and send it to a third-party server for analysis and for control. So that piece of malware ran for more than a year before it was actually intercepted and removed from the internet. So you don't really know when the application looks like and acts like the brand that you're expecting and having a trust relationship with is going to do bad things against you. So, given the escalation in all of these attacks, this has resulted in a large number of activations of governments around the world. We're now seeing a huge number of data privacy laws, of citizen and consumer protection acts around the world. I think pretty much all of the states in the US have them now, started with the California Consumer Privacy Act, and pretty much they all have them now. And it's not going to stop there. We've always known that we've had market vertical compliance regulations, so anyone working in e-health will know about HIPAA. Anyone working in mobile banking or fintech will know about CPOC, SPOC, MPOC, EMVCO, all of these standards which basically say these are the attacks that are going to happen to you in the real world, and this is what you need to do to your application in order to harden it against these attacks. So as I said before, where do these attacks begin? Well, reverse engineering is always the starting point. Hackers, like engineers, want to know how something works. They're very curious people. They need to understand the mechanisms, the architecture, so that they can develop something that's much more sophisticated. So as I said, that's generally very easy to achieve on Android. We can download the APK to the device. We can use the Android debug bridge to gain access to that package, or packages if it's been an Android app bundle. Recover that to a PC, and then use very simple tools, Java decompilers, Kotlin decompilers, to gain access to the high-level code. And as you know, that high-level code is very easy to understand. And walking things through Smiley representation, very easy to remove or add functionality to an application and recompile it very easily. So with a combination of static and dynamic analysis, attackers can gain a very good understanding of an application's functionality and therefore develop very sophisticated malware to take advantage of that. So this all sounds bad so far, but there are a number of organizations and frameworks that we can use in order to guide our development and guide how we will protect our applications in the real world. The Open Worldwide Application Security project is a great example of that. The OWASP Mobile Top 10 will tell us about the common vulnerabilities that attackers use in order to construct malware against our application. So it's a really good checklist, and certainly the sort of checklist that external pen test organizations will use in order to test your application for attacks. Now, there are a number of techniques that we can deploy in our application either during compilation or post-compilation to protect against these attacks. So if you think about what code obfuscation, everyone in here who's an Android developer will know the word obfuscation, but primarily know it as symbol obfuscation that we get with ProGuard and R8. Well, this is not really a security technology, it is a minification technology. It's to minimize the overall size of the the application that we deliver to the marketplace. It does have the benefit of removing human readable context from the package names, from the class names, from the method names, but it doesn't alter the bytecode of the application in any way, shape or form. And with dynamic instrumentation, an attacker will know that package A, class A, method A is the authentication class, or will know that this is an encryption class or a payment class. So the dynamic instrumentation capability is the important thing in the attack here. But if we apply code obfuscation, we can really stop that reverse engineering journey in its track. What that means is that we can hide our APIs. So if an attacker can't discover our APIs, he cannot develop malware to abuse them. He cannot remove functionality for authentication from an application. And there are a number of techniques that we apply in order to really scramble this code. We can rename variables, we can flatten if statements, we can unroll for loops, we can inject junk code, we can inject goto statements to scramble the call graph of the application, and they all have the benefit of making this application impossible to understand statically. Here's an example where I've used the JADEX Java decompiler and an application that had no symbol obfuscation, no protection in it at all. And very simply, not only do I gain access to all of the third-party packages that my application is using, but I get access to the core activities and intents inside the app. And it's the bytecode representation here that I'm looking for. These are the APIs that I want to attack with my malware or to statically modify. But with code obfuscation, we can do things sophisticated that will actually remove the entire API from the bytecode. This is a technology called DEX encryption. So what you see here is you're left with the Android resource class, but none of the third-party APIs are now visible. None of that bytecode can be understood, and therefore would be very difficult to modify. We can also add anti-tampering to our application. Now, tampering takes many different forms in Android. We can repackage a basic application like we saw with WhatsApp Gold. We can modify the bytecode. We can modify the binary code. We can re-sign an application. Android operating system only cares that the binaries have been code signed. They don't check who is code signed. We can clone an application so that we can have multiple users interacting with an application on a single device, and that's a common attack vector as well in fintech and mobile banking applications. But we can layer these anti-tampering checks into our application so that during runtime we're constantly checking that no one's tried to modify the memory of our application, that nothing has attached to our running process. We can also add in environment checks. So obviously we want to know that the device that our software is running on is secure enough. Anyone who uses Firebase today will know that there's anti-debugger checks. So that there's lots of checks that are added again to the bytecode. But again, if that bytecode is not obfuscated, if that bytecode does not have anti-tamper, then it's very easy to identify it and to remove it. However, with strong environmental checks, we can determine if the device has been rooted. And obviously there's very sophisticated routing technologies, so whether or not we're running Magisk with Hide Manager or Magisk at the kernel level, we definitely want to be able to know that that software is running because it gives us elevated permissions on that device, and those elevated permissions can certainly be used against us. We can do sophisticated debugger detection, so ptrace detection, strace detection, more heuristic detections to see whether or not anything is attaching to our application. We can check for emulators, and this is very important. Some people don't believe that emulator detection is significant. However, if you think an attacker might have 10, 20 physical devices, well, we would say that that was a limited attack. But if they've sourced 10,000 usernames from the dark web, they can easily then spin up 10,000 instances of an Android device on something like Bitbar or BrowserStack or some other virtualization platform, and then attack you 10,000 times very quickly. So being able to detect emulation is super important in order to limit attacks scaling against you. Hooking framework detection is probably one of the most important detections that we have out there today. This is going to be the future of attack vectors. Gadgets are pushed into your application. Those are the gadgets can then be command and controlled by a simple JavaScript to identify the activities, the classes, the methods, and make runtime modifications. And overlay detection. So overlays are used validly. If we think about the Android accessibility API, there are overlays in order to do auto-clicking. in order to inject credentials into an application, but they can also be used in order to abuse those APIs as well. So what we're really talking about here is we need mitigation controls, risk mitigation controls. We need ones that are preventive, detective, and corrective. Well, everything that we talked about in terms of the checks are the preventive pieces. The detective pieces is where the state of the art in cybersecurity is moving towards. So we want to be able to have continuous real-time threat detection. So like we have in Firebase for detecting issues with our runtime of the code, with a real-time continuous threat detection, we can see all of the risks that our app is suffering from. And where we get responsive, we get a large amount of behavioral data. Someone has installed our application, tried to attach a debugger, uninstalled the application, install the application again, try to attach an overlay to it. So with this behavioral data, we can very easily classify an application on a device as being high risk. And once we know that, we have automation in place to say, please send a kill switch to all of these applications. I cannot trust them, and I do not want them to weaponize the APIs in my application against me. So Verimatrix as a company, we have been doing this for 25 years, and this is now the state of the art of our technology, that we can protect applications using all of these techniques automatically. We can deliver the real-time threat intelligence either via our own dashboarding system or via SIEM connections. We use AI and ML to massively process a data lake of hundreds of millions of devices from more than 800 customers around the world, so that we can accurately reflect zero-day and new emerging attacks, because we focus on the mechanisms. We don't focus on the signatures of these attacks. And detecting those mechanisms allows us to shut down these attacks very quickly. Okay, sorry, I realised that we only had 20 minutes here, and I can talk about this stuff for 24 hours. So I wanted to make sure that we had enough time in order to answer and ask any questions. So I didn't want to frighten you too much, but I think as software engineers, we need to be aware of the fact that these attacks are scaling against us, and the escalation is continuing around the world. Given the fact that we've got market and government regulation now, we need to make sure that we're building security not only into our applications architecture, but that we've got the tooling in order to help us as well.
Raise your hand if you have any questions.
Maybe you guys could raise your hand. Does this resonate with anyone? Has anyone seen any of the examples that Keir shared in their environments? I'd be curious. No?
It's also important to note,
like some of the attacks and whatnot that he shared, is that something you guys are seeing?
it is important to know that more than 45% of organizations in North America have reported in the last 12 months attacks using their mobile applications against their back-end infrastructure. So I don't know if you're aware of that statistic. Companies don't often like to talk about this, but these attacks are ongoing. It's not to say that the attacks are always successful, but companies are definitely seeing instances of these attacks. Hi.
I'm interested in like how you're monitoring the. I'm interested in how you're monitoring the customer behavior when they actually install the app. It's like they're collecting some user analytic data to, I guess, the company backend. Do you need any user permission to collecting those data?
Yeah, that's a great question. I mean, Verimatrix, we don't process any app-level information or any user-level information. And that's also very important for us in order to comply with these government regulations. We cannot store or process any person-identifying information. No usernames, no passwords, no IP addresses, nothing like that. Otherwise, we would breach those data privacy regulations ourselves. So what we're interested in is purely security metadata. We call them indicators of attack. And today, we will process about 50 indicators of attack from a device. So for us, that would be things like this device has developer mode enabled. Someone has tried to attach a debugger. Someone has tried to modify this version of the application. There's some form of data proxy in place, like man in the middle, or even a VPN. If you think about how Netflix runs their business, They like to make sure that a connection is not being VPN'd because they have license requirements not to distribute content to countries and that they don't have these things in place. So that security metadata allows us to stay within the government regulations, but still gives us more than enough data in order to understand the behavioural analytics. So when we say behavioural analytics, we talk about the behaviour of the application on the device, not the functionality of the application.
Right, but like since you mentioned it's gonna link to some account, so will there be? So how do you identify the account, right?
Okay, on our side of this whole processing thing, it's completely anonymized. We would not know that account data. But with our system, what an organization can do is when we give them a unique identifier for this application on this device, they can tokenize that. So on their side of the end user license agreement, they can say, okay, this unique ID that you've given me, please call it user 1234. Now, any security information events that Verimatrix then sends to our customers, we will say, hey, someone, user 1234 is trying to run his application on a rooted device. They will then be able to de-anonymize because they will know a username, they will know a telephone number, they will know an email address, and that allows them then to complete the customer journey. So, for example, in the cases of identity theft theft, they would want to know, okay, someone is impersonating user 1234 on an Android device, but we also know that this person is connecting on an Android tablet or via his smart TV or his smart fridge. So they can then send a kill switch to all of the devices associated with this tokenization to ensure that no user ID theft can be used against them and or weaponize the APIs within the application.
Yeah, makes sense. Last one, really quick one. Do you also have some solutions for like API spamming?
Yeah, like I said, we focus a lot on the way that the mechanisms of these attacks occur. So the anti-tampering and the code obfuscation inside our application will stop that APS spamming from occurring.
Okay. Yeah, cool, thanks.
In one of the slides, there was the screenshot detection and one of the environment checks, I think.
Yeah.
So do you just block all screenshots, or what do you use? Because some people want to take screenshots of some parts of the app.
Sure. With our system, we have a default response, and that default response is just to say bad things, don't trust, kill app. But that obviously does not fit 100% of the use cases. So with our tools, you can define your custom responses to these attacks. So that means that you just basically at protect time say, hey, if you detect root detection or overlays or emulators or something like that, please execute this method. Could be something as simple as to display a toast dialog to the user to say, hey, please be aware of the fact that we're going to limit the functionality of the app, or please unroot your device before you continue. But with our real-time continuous threat detection, we have a range of flexible countermeasures that you can execute. So it's very customizable depending on your market needs, your application needs, your user needs.
And what about the performance after the obfuscation or the extra security checks you have?
Yeah, I mean, the cost of obfuscation is going to be an increase in the size of the binary, right? That's the cost for that security. With our tools, we're probably going to impact the size using all default configurations by about 30%. However, with our tools, it's very easy to specify packages, classes, and methods that we just do not want to treat with the Verimatrix tools. So it's very easy to manage that. The runtime performance impact is pretty much invisible to the user experience. For any given method, we probably impact it by about 3 or 4% of the processor usage. So again, we can get down to very tight timing requirements. So if you're processing a payment using NFC, or if you've got a media application that's rendering 30, 50 frames per second, our tools won't impact that at all. And in the very slight cases where we have impacted performance, this management method where we can say, please ignore this package or this class or this method, allows us to maneuver around about that problem very easily. But our solution is automated. I mean, that's the real benefit from an engineering point of view. We don't want you guys to have to be security experts. We take your final application, we inject the defenses into it, and then we can very quickly iterate if we need to manage any specific performance or size metrics. Excellent. Well, listen, thank you very much. I didn't actually start with the joke today, but I would like to finish with it. And it's one of my favourite jokes. And what is a company chief information security officer's biggest fears? Anyone who works for the company and anyone who doesn't work for the company. So I think that really shows where we're at cybersecurity. We don't trust our own people, and we don't trust the people who are using our applications. So please, protect your applications. Thank you.